Now we're going to create a polygon feature describing the area of Crocker Beach adjacent to campus on the Fish River. And we're going to do some exercises with the calculation of area for this polygon. So first we need to create the polygon. We're going to use a shapefile for this. We can go to one of our working folders, right-click on the folder and say New Shapefile. We're going to make that a feature type polygon. We're going to call it Crocker Beach. And we're going to give it the coordinate system NAD 1983 UTM zone 19 north. Okay. And now to create the polygon we need to first begin editing. We can right-click on Crocker Beach, edit features, start editing. And then we can go to create features. If we don't have this tab here, we can go editor, editing windows, create features. We need to select Crocker Beach and we're going to create a polygon. So we're going to start at the corner here, go to the road, one click for each vertex, follow along the bank, now when we want to finish our feature we can either double click or right click and finish sketch. Now we have a shapefile with one polygon feature showing Crocker Beach. We can say editor, stop editing. Yes, we want to save these edits. We can change that to a hollow shape with a nice thick yellow line. So there's Crocker Beach. Now, let's calculate the area of Crocker Beach. To do that, we need to open the attribute table by right-clicking, open attribute table. We need to first add a field. We use that from the drop-down menu of this first button on the left. Add field. We're going to call this acres, and we're going to use type double. Okay. Now this is just a blank field with a 0 by default. This does not actually connect to anything. I could have called this anything I wanted to. Just because I called it acres doesn't mean it knows it is acres. So if we right click on acres, we can say calculate geometry. Yes. And both the shapefile and my data frame are in NAD 1983 UTM zone 19 north, which is good for our local area. So we want to calculate the area of this feature, and we want to calculate in the units of acres. Just go ahead and hit OK. Yes. And we see this is a 6-acre area adjacent to campus along the Fish River. Very good. Now, where it gets tricky, if for whatever reason you brought in your data in WGS 1984, you'd be most likely to do this if you brought this in from a GPS, because WGS 1984, which is degrees, minutes, and seconds, is the native language of the GPS. We can change the projection of the data frame by right-clicking on our data frame title, layers, going to properties, and the coordinate system tab, Global Coordinate System WGS 1984. And that warps and distorts our image. It's doing that because as you get closer to the poles, you get more distortion, and we're about halfway up, halfway between the equator and the pole, so we get some major distortion of our image. Now, if we go back to the attribute table, and if we right-click on acres again and say calculate geometry one more time, we have the option to use the coordinate system of the data source, which is our shapefile, and we can select any of these if we do that. But if we use the coordinate system of the data frame, area is disabled, perimeter is disabled. You can only have x and y coordinates of the centroid, which is useful for some applications but not area. So it won't even let us do that. So we can cancel out of there. Let's try another one that is common for data imported online. So go back to Properties. And if you're importing data from online sources, you will also often get it in WGS 1984 Web Mercator. The Mercator projection was originally developed in the 1500s for the purpose of nautical navigation. It's useful because it preserves angles, but it distorts shapes. So you can see our shape is again distorted. Let's go ahead and try to calculate area. Now we can right-click on acres, calculate geometry, and use the coordinate system of the data frame, and it will allow you to calculate area. So let's say acres, OK, yes, oh, now it's a 13-acre stand. And this is because the Mercator-based projection gives up on area completely so that you can have a easy navigation in a sailing ship from one point to the next, holding one constant compass bearing. It is not made for land measurements or navigation in the field. It is for shipping transportation across oceans. Very useful for that, but useless for calculating area of Crocker Beach, a forest stand, a property boundary. So this is one of the ways you can get yourself into trouble calculating area. Say you calculated this forest stand to be worth $1,000 an acre. If you had 13 acres, that would be maybe something you could go in for and bring in some harvesting machinery to take care of. Obviously not right next to the river. But if you only had 6 acres, you would get yourself into a pickle. If you assumed you had $13,000 worth of wood and you only had 6, that would be an awkward conversation with your logger. So let's bring this data frame back into NAD 1983, UTM Zone 19 North, which is accurate for our region. And now we can recalculate that geometry and get our area of 6 acres, which is correct. Now, the other way to get yourself into trouble is by splitting this polygon in half and not recalculating the area. So let's begin editing again. So right-click, Edit Features, Start Editing. And now if we select this polygon of Crocker Beach, we have the option to split the polygon, or cut the polygon. Let's say we want to separate out the field section from the forest section. We have to begin with our first click outside of the polygon, and then we can click as often as we want to define vertices. And now we have to end by clicking again outside of the polygon. So now we've cut our polygon into 2. We can stop editing, save our edits. Now let's look again at the attribute table. So now we have 2 shapes within this Crocker Beach area, but both have retained the same attribute of acres. This obviously can't be so. This whole thing was 6 acres. This part and this part have got to be less. So what you have to do every time you cut a polygon or clip a polygon using another feature is recalculate the area. So right-click on acres, calculate geometry, and we want acres using NAD UTM Zone 19 North. And now we can see that the forest portion is 4.768 acres and the field portion is 1.27 acres.